Hi guys, so let's solve a couple of the questions on stoichiometry problems. And before we start, just short revision through the formulas we apply in our calculations. The first formula, mole equal to mass divided by molar mass. So mass here will be in the grams. This formula you will apply and use only when you will have or you will be asked to calculate the mass. The second formula, it's a mole equal to number of the particles. So unit, it's a particles. Here it can be atoms, ions, molecules, etc. Divided by Avogadro number, 6.02 multiplied 10 to the power 23. The same here, guys. If you will be asked or provided by the number of the particles, you will apply the second formula. And third formula, mole equal to volume divided by gas constant, 22.7 in IB. So the unit here will be decimeter cube. The third formula, guys, you will apply only at standard temperature and pressure, and only for gases. Okay, so and the last, guys, formula, when you will solve question on the solutions, you can face with this formula. So fourth one, it's about the concentration. So you know that concentration equal to mole divided by volume. So you can find that mole equal to concentration multiplied by volume. Volume here will be in decimeter cube. Okay, this is the fourth and last formula. Okay, so let's start to solve problems. The first one, how many grams of water can form if, let's highlight here, if 113 grams of acetylene burned? We already provided with the equation, but still, guys, the zero step, before you will start your calculation, first of all, you need to balance your equation. And usually we start from the carbon, after we move to the hydrogen, and last one will be oxygen. But here, before you will start, just check. On the right side, you have 2 oxygens and 1. So 2 plus 1, it will be 3. So this is an odd number. What does it mean? It means like in the end, you will multiply everything by 2. So that's why we can just start with a 2 here. And after, as usual, so on the left side, 4 carbons, 2 multiplied by 2. On the right side, 4. On the left side, 2 multiplied by 2, 4 hydrogens. On the right side, 4. And the last one, it's oxygen. Here we have 8 oxygen, here we have 2. Overall, it will be 10 oxygen. Put 5 and you will get 10. So guys, we finished with the balance. And the first step, whatever they will provide you, they can provide you with a mass, they can provide you with a volume, they can provide you with a number of particles. They can provide you with the concentration. They even can provide you with the density and other values. Whatever they will provide you, first of all, guys, you need to convert it to the number of moles. That's your first and the most important step. Let's do it. So they provide us with 113 grams of acetylene. The first step, we need to find the number of the mole. How you will do it? We will apply this formula in order just to find it. Mole equal to mass divided by molar mass. Mole equal to mass of that acetylene, it's 130 grams. And the molar mass of that acetylene, molar mass of the carbon 12 multiplied by 2. Molar mass of the hydrogen 1 multiplied by 2, and overall it will be 26. So divided by 26 gram per mole, 435 mole here. Okay, this is the first and most important step. First step. Okay, after you will get the number of the moles, you can find the number of the mole of other compounds. How you can do it? Guys, it's simple proportion. The number of the moles will be directly related to the coefficient. So for example, if you will use 2 molecules of acetylene you can produce 4 molecules of carbon dioxide and 2 molecules of water. The question here, if you will use 435 moles of acetylene, how many moles, for example, they ask us about the water, of water they can produce? Let's try to find it. Here you will use, let's write direct proportion. Guys, it's simple here. For example, if you will have 10 oxygens, so 10 moles, you can produce 8 moles of carbon dioxide and 4 moles of water. If you have 5 moles of oxygen, you can produce 4 moles of carbon dioxide and 2 moles of water. If you have 15 moles, 3 times more, yeah? So 4 multiplied by 3, it will be 12 moles, and 2 multiplied by 3, it will be 6 moles. Guys, I hope it's obvious that here, like, direct proportion between the moles and between the number of the mole and coefficients. Okay, we can start. If you have 2 acetylene, you can produce 2 molecules of water. So this is a coefficients. And if you have 435 moles, how many moles you can produce? This is a moles. Okay, X will be equal to 435 multiplied by 2 divided by 2. 435 mole. Okay, so let me write this. And that's the most important step, because now you have, let me highlight also with the green one, just to show the proportion here. And now you have the number of the moles of water. You know molar mass of the water, I hope, guys. So 2, it's a molar mass of the hydrogen multiplied by 2, plus 16, you will get 18 gram mole minus 1. So this is a molar mass of the water. Yeah, so you know the molar mass, you know mass, you can easily find mass. Mass will be equal to mole multiplied by molar mass. So mass equal to mole 435 multiplied by 18 gram divided by mole. Okay, so mass will be equal to 78.3 grams of water. Guys, if you will use 113 grams of acetylene, you will produce 78.3 grams of water. First, you need to find number of the moles. Okay. The second step. In the second step, guys, you will do proportion between the coefficient and the number of the mole. They are directly related to each other. And the third step. Here, guys, you will do reverse calculation. So, guys, let's solve the next question. I hope it's clear how to solve this one. And here, camels store the fat tristearine in the hump. If 22.7 decimeter cube of oxygen is consumed at standard temperature and pressure, so pay attention please here, standard temperature and pressure, you automatically will apply the third formula with the volume. How many grams of water are produced? Equation, guys, already balanced, because here it's coefficient really huge. That's why, in order just to make it faster and clear, we did it for you. But still, zero step, you need to balance the equation. We have amount of the oxygen. So it will be 22.7 decimeter cube. And they ask us to calculate the mass of the water. So mass here will be unknown. The first step, guys, whatever they will provide you, you need to find the number of the mole. Mole equal to volume divided by 22.7. Okay, so mole equal to volume of oxygen, 22.7 decimeter cube, divided by gas constant, it's 22.7 decimeter cube, mole minus 1. Obviously here you will get 1 mole. Okay, the second step. In the second step, you will find the mole number of the water. How you will do it, guys? Here you can find coefficients, yeah? So let's change the color. Let's do it. Okay, so here you can find coefficients. So if you will use 163 molecules of oxygen, you will produce 110 molecules of water. So if you will use 1 mole, what will be the mole of water produced? How you will do it? 163 will be equal to 110. 1 mole will be equal to X. So X will be equal to 1 multiplied by 110 divided by 163. You will get 0.67 mole. Okay, guys, sorry, I will not follow the decimals because I will save my answer on my calculator. Okay, now you have the number of the mole of the water. You know molar weight, so it will be 18 gram per mole. You know the mole number, and you can easily find the mass. Third step, it's a reverse calculation. If mole equal to mass divided by molar mass, mass will be equal to mole multiplied by molar mass. Mass will be equal to, because of the lack of the space, I will not write decimals, so 0.67 moles multiplied by 18 grams per mole, and you will get the mass of the water. So multiply by 18, it will be 12.1 gram of water. Okay, guys, so if you will spend this number, 22.7 decimeter cube of oxygen, you will produce 12.1 gram of water. In the first step, you will find the number of the mole. In the second step, here, you will do proportion between the coefficient and the number of the mole. And in the third step, you will do reverse calculation because they ask you for mass number. That's why you will find the mass. Okay, so let's move to the next question. Here the same conditions, but they ask you to find the mass of tristearine required to produce 1000 gram of water. They provide you 1008 grams of water, and they ask to find the mass of tristearine. How you can find the mole number? Mole number equal to mass divided by molar mass. Mole will be equal to mass of the water, gram, divided by molar mass of the water. Molar mass is 18 gram mole minus 1, divided by 18 gram mole minus 1. It will be, let's change color, 55.56 mole. If we have mole number of water, we can easily find the mole number of tristearine because our equation already balanced. There is no need to balance it again, but still, let's highlight it. And we need to find the mole numbers here. How we'll do it? 100, let's write 2, it's 110. 55.56, it's X. Okay, so X will be equal to 55.56 multiplied by 2 divided by 110. 1.01 mole of tristearine. will require it in order to produce 55.56 mole of water. And the last step, you'll find the mass. Mass equal to mole multiplied by molar mass, you know it from the previous example. Mass will be equal to 1.01 moles multiplied by molar mass of the stearine. Okay, here is a huge molar mass, that's why I'm here. Let's do it together. Molar mass equal to 12 multiplied by 57 plus 1 multiplied by 110 plus 16 multiplied by 6. 684 plus 110, and 16 multiplied by 6, it will be 96. It's 890 gram per mole. Mass will be equal to 0.9 grams of tristearine required in order to produce 1 liter or 1000 grams of water. So guys, I want to just mention that I use round number of the molar masses from the periodic table because the aim of the video to show you calculations. But when you will do your calculations, I will ask you to follow the periodic table decimals just in order to get the more precise, more accurate values. Thank you very much for your attention. We will continue with the limiting reagent.